Welcome to the another lecture on Shannon's fano encoding algorithm. This is example number 3. Already in previous class we discussed the two examples. One more example coming we are discussing now. The problem states that consider a source S is equal to S1, S2 with probabilities 3 by 4 and 1 by 4 respectively. Obtain Shannon's fano code for source S, its second extension and third extension, and calculate efficiency for each state. The second and third extension you have to solve. Second and third extension you have to solve. Okay. Here for basic circuit. Okay. For basic circuit solution. For basic source, okay, we have got S1, S2. S1 probability is 3 by 4 and S2 probability is 1 by 4. Only these two. So that, and code for this is 1 and 0. For this, the code is 1 and 0, and length is 1, 1. S1 is also 1 and S2 is also 1. So we have to find the average length. Okay, average length, we know the formula. Average length, that is L is equal to summation of I is equal to 1 to 2 Pi into Li. Pi is 3 by 2 and Li is 1 plus 3 by 4, Li is 1, and P2 is 1 by 4 and its Li is 1, so that the length is 1, so that this is 1 minutes. L is equal to 1 minutes per message symbol. 1 minutes per message symbol. And same time the entropy H of S is equal to summation of I is equal to 1 to 2 Pi log 1 upon Pi. Pi log 1 upon Pi. You can write this as 3 by 4 log 4 by 3 plus 1 by 4 log 4. 1 upon Pi means 1 upon 1 by 3 by 4. So that 4 will come to the numerator and by 3. So solving this, we will get the answer it as 0.8113. This is bits per message symbol. So that we will have that efficiency. Efficiency is given by, that is efficiency is equal to, efficiency of coding is given by H of S divided by L. What is H of S? That is 0.8113 divided by 1. So the percentage is 81.13 percentage. Percentage is 81.13 percentage. And redundancy, the code redundancy is given by 1 minus 1 upon efficiency, 1 minus efficiency, so that its percentage is how much? 18.87%. Redundancy is 18.87%. This is for the basic source. We have calculated the code. As this is, they have got only two symbols. So one symbol represented by the 1 and another symbol represented by the 0. Because of this, we have the length both 1, and hence we find the average length, that is 1, and the entropy 0.8113, and the efficiency 81.13%, and the redundancy is 18.87%. So that for second extension source, we have 2 to the power of 2, that is 4 symbols. We have 2 to the power of 2, that is 4 symbols. Second extension. For the second extension, we'll have 2 to the power of 2, that is 4 symbols. 4 symbols. How? S1 write 2 times, S2, so that here S1, S2, S1, S2. This is the symbol. Okay. And their probabilities. S1 is 3 by 4, S3, S2 is 1 by 4. So into 3 by 4 into 1 by 4 into 3 by 4 into 1 by 4, so that the first symbols S1, 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 S2, S2, S1, S2, S2, their probability is 9 by 16, 3 by 16 and 3 by 16, 1 by 16. These are the probabilities of the newly obtained symbols. Okay, probabilities of newly obtained symbols. For these symbols, we have to use Shannon fano encoding algorithm. Okay, so that I'll write, okay, S1, 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 S2, S2, S1, S2, S2. Okay. Okay. And the probability is 9 by 16, 3 by 16, 3 by 16, 1 by 16. They are all arranged in the non-increasing order by default. Okay. Now, okay, I'll separate this block and this block. According to Shannon fano encoding algorithm, the block what we split should have approximately equal probabilities. Here it is 9 by 16. Now the bottom block is 7 by 16. So first I'll assign this one and these the zeros. These will be assigned with zeros. Okay, again. This what we'll do? 3 by 16 and 3 by 16, 1 by 16. I split this 3 by 16 and 4 by 16. Okay. So, for this, again 1 and both are 0. Okay. Again, this is further splitted. That is 3 by 16 and this is 1 by 16. Again, the topmost block is 1 and the bottommost block is 0. So, for this, here I write the code. Okay, here I write the code for this value. The code is 1 for first one, and second it is 0, 1, third is 0, 0, 1, and the fourth is 0, 0, 0. And the same, I'll write the length of the individual code. First one's length is 1, second is 2, third is 3, and fourth is also 3. Now I find the average length. Average length is obtained by the formula I is equal to 1 to 4. Now we have got the 4 symbols. I is equal to 1 to 4 with Pi Li. This is Li. So, we'll have this as, what is Pi? 9 by 16 into 1 plus 3 by 16 into 2 plus. So second probability is 3 by 16, first probability 9 by 16, third probability 3 by 16, and their corresponding length. Multiply should corresponding length 3 by 16 into 3 plus 1 by 16 into 3. And all doing this, we'll get the solution at 1.6875. 1.6875 minutes per message symbol. See, we know that h of s square, second extension, can be found using all this probability, or that can also be found the formula which has been discussed in the previous module, that is h of s square, second extension is equal to 2 times the first extension entropy. So that is 2 into 0.8113, and the answer is 1.6226. 1.6226. See, now I know that average length and I know the entropy for the second extension. So I can find the efficiency. Efficiency is equal to h of s square, or you can consider this as L2 also, by L2. Average length L2, because second extension you may consider that one, 1.6226 divided by 1.6875, and the efficiency is 96.15%. 96.15%. Okay, and redundancy 1 minus efficiency. 1 minus efficiency, so that 1 minus 0.9615, that is 3.85 percentage. Redundancy is 3.85 percentage. See, if the efficiency of the first extension source is, okay, I'll call this as a site 2, okay, 8R2, and this one for second extension. In the previous, for first extension, we got the efficiency of 81%. Now it is 86.15%. See that efficiency increased in the second extended source. Similarly, okay, I'll go for the third extension now. I go for a third extension. For third extension, okay, for the third extension, that is, we got the two symbols, 2 to the power of 3 is equal to 8 symbols. We'll have the 8 symbols for the third extension. Okay, how to calculate that one? See, in previous we got S1 as a 9.16, S1 S2 as 3.16, S2 S1 as 3.16, and S2 as 1 by 16. Okay, how to write this one? Okay, first consider S1 2 times, because again here I have to write S2 S1 similarly. So S1 S2 okay. Okay, for this S1 again we will have this S1 S2. It is similar to truth table what we studied in the lower semester digital electronics. For 3 bits, 0000001, like that. Okay, same fashion it has been done over here. See, and we know that also we have got that S1 is 9 by 16. This is also 9 by 16. 3 by 16, 3 by 16, 3 by 16, 3 by 16, 1 by 16, 1 by 16. Multiplied by S1 means it's a 3 by 4, S2 means 1 by 4. 3 by 4, 1 by 4, 3 by 4. And the final result, the probability of the third extended symbol, we can write this as numerator 9 and then it is 3. So it is 27 by 64. This is 27 by 64. Okay. Similarly, next is 9 by 64. 9 by 64. 3 into 1 is 3. 3 by 64. 9 by 64. 3 by 64. 3 by 64. 1 by 64. We have written the code as shown here. Okay. I'll arrange this code. See, with probability. Okay, this should be See, again for further solution, it has to be arranged with respect to the non-increasing probability. So it is 1, and this is 2, 3, 4, 5, 6, 7, and 8. Okay, 5, 6, 7, and 8. I'll write your. I'll rearrange in tabular as shown below. It's rearranged as shown over here. Okay, so that here what we do, I'll make this as the entire one symbol, one block, and this entire as the another block. For this, we get, I'll write the code. This as a 1 and these are zeros. Okay, these are the zeros. Okay, next. Further, how much? 9, 18, 27, 30, 33, 36, 37. 37 is that. So what I do, 37 means 16, 36 means half of that is 19. So I'll make this as an 9 by 16 and 9 by 16. These two sub-block, and the remaining 9 by 16, 3 by 16, 3 by 16, 3 by 16, and 1 by 16. It's not that exactly it should be same. Okay, it's approximately should be same. So this is 1, 1, 0, 0, 0, 0, 0. Again, this is further splitted. I'll split this as 9 by 16 into two subsections. Similarly, this 9 by 16, this is 3 by 16, 3 by 16. Sorry, this is not denominator 16. These denominators all are 34. All are 34. Denominators all are 34. Sorry. The denominator, sorry, 64. Okay. I'll rewrite. Okay. This is 9 by 64. 9 by 64. Then 9 by 64. 3 by 64. 3 by 64, 3 by 64, 1 by 64. And I'll code this as the 1 and these are as zeros. Okay, again. Again, this is further splitted as 9 by 64 and 9 by 64. This is 9 by 64 and remaining 3 by 64, 3 by 64, 3 by 64 and 1 by 64. Okay, I will write the block. So this is 1 and this is 0. Again this part is 1 and the remaining part is 0. Remaining part is 0. So again this is 3 by 64, 3 by 64 in one block and 3 by 64, 1 by 64 in another block. Okay. With the upper block with ones and lower block with zeros. Similarly, again further 3 by 64, 3 by 64, with 1, 0, 1, 0. I'll write the code. Okay, I'll write that code Okay, the same symbol. Okay, rewriting that in tabular column is as shown here, and writing their codes. Okay, writing. See, for 27 by 16 I have only one digit 1, and for 9 by 16 second 0 1 1, and for second third symbol 0 1 0, and respectively. See, length of their codes. The length of that codes are, this one is, first one is 1, second one is 3 3 3, here it is 5 5 5 5. The length of the codes. Okay, finding the average length. Okay, after finding this, you'll find the average length. That is, as this is third extension, I'll call this as L3. Summation I is equal to 1 to 8 pi li. Pi li. That is 27 by 64 into 1 plus 9 by 64. 1, 2, 3 are same. So, and symbol is 3, and there are 3 terms. 9 by 64, there are 3 terms. So, plus 3 by 64, and their code length is 5. 3 by 64 and their code length is 5, and we have got 3 such values, and 1 by 64, its code length is 5. So 1 plus 3 4, 4 plus 3 7, 7 plus 1 it is 8. And solving this one, so we get the answer 2.4688. L3 is 2.4688. So similarly, we can find the entropy of second third extension, that is h of s cube is equal to 3 times the h of s, that is 3 into 0.8113. 3 into 0.8113 will get that as 2.4339. So that we'll find that efficiency. Now we'll calculate the efficiency. So efficiency is equal to h of s cube divided by L3. That is, answer is s cube, that is 2.4339 divided by 2.4688. That is 98.58. 98.58. That is 98.58 percentage. And the redundancy is, 1.4 percentage. Redundancy is 1.4 percentage. Okay, see that from this problem says that as the extension is increased, okay, and means the symbols are more, and the efficiency will also become the more. Okay, efficiency will also become the more. Also, we can follow on another step, that see, sometimes if know that in some more problems will occur, if the third extension is less than that of the first extension, then you change the procedure of Shannon fano encoding. Okay, that is the splitting the block. So always follow one procedure. If you split, okay, see here we are splitting this block. At the topmost it will be 1, okay, and remaining blocks, when they are not approximately equal. See, the bottom is 9 9 9 27 30 36 39 40. 27 plus 37 27 30 30 36 30 37. See, this is 27, this is 37. In this case, split this one separately. Okay, the separate block. Okay, further, okay, this is 18 and this is 19. So now make equal. Try to make approximately equal. Okay. If not, if it is too large values difference, make the single block. Okay. Make the single block. See, the next step is it is 18. This is 19. So you have combined these two to form a single block and this one. Okay. Next here in the bottom this one. This is 9. This is 10. Okay, this is 9 and this is 10. Okay, next this is 6, this is 4. Okay, preferably give the denominator section more probability. Preferably give the denominator section the more probability than the bottom section more probability than the top section. With that, the efficiency will be increased further more. Okay, thank you. We'll meet in the next problem. Thank you.